Okay, we'll be talking about the writing classes better lesson in Blackboard. So let's go ahead and get started. We had some questions, and I apologize. I'm going to be using the camera, which is probably not what you guys want to see. But we had some questions related to, to static, and the whole question of static gets caught up in the opposite of static, which is objects. And no, didn't want to do that. So, don't know if you can see this. This little thing is just a cookie cutter. And I don't have any cookies with me, but I do have a cookie cutter. And what I could say is a cookie cutter represents a template for a cookie. And even without cookies, there are some things that I can tell about the cookies made from this cookie cutter, namely the shape, the area, and so forth. So if I had 1,000,000 cookies or one cookie, this shape is going to be what the cookies look like. And so some characteristics are associated with the cookie cutter. Some characteristics, like the dough type, the weight, maybe a topping or something, are associated with each individual cookie. If I had 1,000,000 cookies, I might have a different types of dough, but I would have only one shape because it's associated with the cookie cutter. The same thing holds for classes and objects in Java. Oh dear, you can only see my icon. Okay, let me try to fix that. Full screen. That didn't help. Oh. Share. Okay. Thanks for telling me that. Is there another? Oh, it doesn't say. Show the conversation. Oh, thank you, Microsoft. If anybody has any ideas about how I can make this camera display larger, I would be most interested in. Okay. Well, okay, just pretend you can see a cookie cutter. Now in Java, a cookie cutter is analogous to a class. And cookies would be analogous to the objects created from that class. A class represents a template for a cookie. And so if I have a file, we tend to name our files based on the objects, the instances. So I would have a file cookie.java instead of cookiecutter.java. But both the class and the instance information is all mixed in together in that file. Things that associate with the cookie cutter are mixed in together with things that are associated with the cookie. And so the way we tell what's associated with the class and what's associated with the instances or the objects is the keyword static. And so if something is static, it is associated with the cookie cutter or the class. There's only one of them, and you don't need any objects to have that static stuff. The deal is there's only one of them. And so if you have a million instances, a million objects, they're all sharing that one static thing. And hopefully all the children are going to play nice, because if they don't, it'll get real confused real quickly. And I'll show you that in the code in just a moment. Let me see, what else? What else did I want to talk about before I switched? And this stuff is all associated with, boy, I don't know whose screen I'm seeing, but it's not mine. I think it might be Desiree's. Let me see if I can hit back. Control. Something else I wanted to mention is this plays into, if you remember back in the first bit of the course, I did some videos on the memory model. And that plays into this too, because the instances or the objects, their memory is allocated in the heap, not on, and so whenever we do a new operation, we're allocating memory off the heap to hold that one object's memory. And so I guess right now we'll just switch to sharing the screen, because, let's see. Okay, can you guys see my Eclipse workspace?
Yes.
Okay, thank you. And feel free to throw things in the chat room. And so this is an assignment. And these funny kind of comments are flags for a program called JavaDoc. And if you downloaded the zip file with the JavaDoc and rummaged through that and open up index.html with a browser, you'll find a nice looking web page with exactly these comments on it. JavaDoc harvests those comments and puts them into a nice web page. So we're going to work on an assignment. An assignment, all objects, all classes should have a fairly simple, straightforward, clear purpose for existing. An assignment represents a single assignment score for a single student. And here we have 4 instance variables: student, assignment name, points possible, and points earned. And we have one constructor already written. It takes all 4 values and just assigns them into the instance variables. Now, what I would ask you to have done would be to write a second constructor, and I'll go on and do that right quick. Public. And this one just has 2 parameters. String. Now, the purpose of a constructor is to do whatever is necessary so that the object is open for business. And so I really need to initialize all 4 of those instance variables. And down here, I was given all 4 values to put in them, but here I'm only given 2. So I'm going to have to come up with some other values, make up some values to put in the points possible and points earned. Now, I could just do assignments here, but I'll show you something that maybe I want to be a little bit lazy and leverage that other constructor. And I can do that by having as the first thing in this constructor the word this, and I'll give it the values I know about. And since that's the 4 parameter constructor, I'll have to give it a couple of other things. For points possible, I'll say, well, the default assignment will have 100 points, and the current score is 0. And so when this constructor is executed, that other constructor down here will be executed with this parameter list. So that's one way to do it. If you use this to reference another constructor, it must be the first thing in the first statement in the constructor you're writing. So that was step 1, and step 1 also over here in assignment play. Step 1, it says make another assignment with a 2-parameter constructor. So I would have and maybe this is also for lab 00. And so now I have another assignment object. step 2, it says add 10 points earned for the other assignment. I guess that will mean Sally here. Yes, because I was adding 5 points for Sophie. So when you're using getters and setters, you have to get what you want, modify the value, and then set it back. So Sally's bonus points will start out, Sally get points earned, and then bonus, and then I'll have to set them back. Okay? Now, one question was, when do you use getters and setters, or when do you put them in? And that becomes an object design kind of question. Getters are very, very common, very, very common. But that presumes that that particular value is going to be of interest to someone. Setters, sometimes you have instance variables that you don't want the user to change once they've been set. So in that case, you just wouldn't have the setter. So next, okay, that was step 2. And if I look at assignment, it has compare score. I need to save all this stuff. Can you guys hear me okay? What's rough doing these things?
Yes.
And I should have a compare. Well, I have a compare score, which is a to-do. That's at step 5. Step 3, use same student to figure out if the student names are different. Okay, so I was looking for the wrong thing. Same student. Now, you see here, this returns a Boolean. Yes, these are the same student, or no, they're not. And it takes as a parameter an assignment object. So that assignment object is going to have student. And I've got a student because the way I'm going to call this is, and I'll just do system out, print line, and oops. Same student as Sophie. So here, Sally is going to be referred to as my default parameter. And that's going to be the object I'm pointing to. Sophie over here is pointing to a different object. So I'm passing the Sophie assignment reference into the code where Sally is the default assignment reference. And so if I just use unqualified student, in this particular scenario, I'm going to be getting Sally. But if I qualify it by other student, I'm going to be getting Sophie. So this is bringing up several things. Since there is no naming collision on the term student, I can just use it. But you could also, and it is not an error, say this student. Either way works. Now, you'll notice that all of these instance variables are private. And this is something else I want to bring out. Private just is not a security mechanism. It is something that says nothing outside assignment.java can access this directly. But this code is in assignment.java. So if I'm given a reference to another assignment object, I can just use that field. Now, in terms of style, that's not my particular way of doing it. But so to show you a different way of doing it, to do the same sort of thing using assignments, I could say get assignment name, which is going to return a string, equals, so I did equals ignore case. What in the world? Sometimes I hate laptops. Equals ignore case, other, get assignment name. And I would want to return that. So is this making sense? Are there any questions so far? Usually in class, people stop me, but which is good. Okay. What else is really important to go through here? Compare score. There was another question about toString and when to use it. The purpose of toString is to return a string representation of the object. Now that sounds kind of flexible or fuzzy or something, and it is, but it's going to differ depending on what kind of class we're talking about. So you can't really say much more about it. Hello and welcome. This is being recorded, by the way. So that's about toString. It just, when you write the class, you decide what a string representation of the object should be, and that's what you put into toString. So are we feeling okay with the assignment class and playing with it a little bit? Are there any questions about that? Okay. If there are, we can go back, just put them in the chat window or yell out. Now let's go to gradebook. And this is where we get into an array list. Now the operative word in array list is the word list, not the word array. And a list is a flexible, stretchy data structure. Unlike an array, it is not fixed size, but all of its elements start with 0. The first element, if there's anything in a list, there's going to be something in the first element. I can't have gaps. So if I add something to an empty list, that's going to go in position 0. If I add something else, that's going to go into position 1. I can add into the middle of my elements. So if I have elements 0, 1, and 2 in a list, I can add something in position 1, in which case the things that were in position 1 and 2 get pushed up to positions 2 and 3. I can remove something from a list. If I remove position 1, the things that were at position 2 and above fall down and start occupying position 1 and above. So does this make some sense? Are there any questions about how a list works? And if I want to have a grade book, I might have a list of assignments. And so I would create that. Did I say what to call it? So let's look at this syntax a bit. An array list is just a class, and we could look it up if we wanted to. And what these, it's referred to as a diamond operator, does is tells Java that this array list is only going to have elements of type assignment in it. This is the variable name, nothing new there. Here I am creating a new array list, so I'm creating something in the heap of type array list. This diamond tells Java, I could put assignment in here if I wanted to, but this diamond tells Java, go figure out what kind of array list I'm going to be assigning this reference to. So Java goes back and figures out that this is going in the gradebook, and a gradebook is an array list of type of element assignments. So that's derived information, and I always need a parameter list. Parameter list might be empty in a lot of cases, but I always need the parameter list. So this creates the array list. Unlike arrays, array lists cannot hold primitives. They can only hold object references. However, all the primitive types, like int, have wrappers. Integer. Double has a wrapper. Double. You'll notice the naming convention, the capital I, capital D. And under the covers, the compiler will give you a lot of help. I can have int I equal 5, integer wrap I equal I. And the compiler, under the covers, will see the primitive int I. It will create a new integer instance, and it will put 5 into that integer instance. And I can go the other way. I could say I is equal to wrap I. And under the covers, the compiler would go to the wrap I object, pull out its integer value, and assign that into the primitive memory. So under the covers, this looks really nice, and I'm glad they do it that way, but this moving between primitive and wrapper class is being done. It's just being done under the cover so that you don't have to do it yourself. So let's create some more assignment objects. And Sally was a sweet girl, but she was not the brightest one. These are Sophie, Sally, and Jack were my dachshunds, by the way. And maybe Jack is working on lab 2. And maybe it has 110 points, and he's got 101 of them. So now I can put these into my array list. And so Sophie will be at position 0, Sally at position 1, and Jack at position 2. Any questions so far? Is this making sense?
Yeah.
Is this what y'all need to go over?
This is really helpful.
Okay. So I can uncomment this. And oh, bummer. Let's do it by hand. And I need to get rid of this stuff. Well, I'll just comment it out. And I want to format. Okay. So okay, let's just run this and see what happens. Let's save it first. So this here. So this loop creates well, the class is coming from that statement there, and here I'm just printing out the 2-string representations. By the way, this get is what type? Well, Gradebook is an array list that holds assignments. So this get is going to return an assignment object. I can't print an assignment. I have to print strings. So when Java sees something where a string is required and it's being given some other type of object, it calls the 2-string method in that class to give a string representation of the object. Now, something we won't hit fully until we get to inheritance, all objects have a toString method, even if you don't have one in your class file. But like I said, we'll just have to hold the details of that until we get to inheritance. So here, I can make a new assignment, I can modify points, or I can compare. So let's make a new assignment. It's going to be 0. The student name, I'll say, is Sally. The assignment name is Lab 2. And so I now have Sally with a Lab 2. And I'm not showing that because I must have put the prints in the wrong place. But let's modify points. And that would be assignment by number. Let's go for 3, because that's where it should have come in. Now, had that new lab for Sally not gone in position 3, my program would have blown up right there, because you can't have gaps in a list. So the new total points, maybe this one only has 90 total points, and Sally did well on it. She got 88.
Okay, so you're saying that if you had wanted to change the points for assignment 4, it would have blown up.
Yes.
Instead of 3.
Try that. Let me do that, but let me first fix this. Why am I not getting all this stuff printed out? Because I have gradebook.size, and one of my minor frustrations with Java is that arrays have .length, which is not a method call. It doesn't have parentheses. Strings have length, which is a method call, so it does have parentheses. Most other collections have size, and all those things are getting exactly the same thing. So, just kind of frustration on my part. And why am I? Okay, so I created a new assignment. Here. Oh, I have to get the element and modify it. So let's kill this. And so select and let's see, create a new assignment. Select the existing assignment by number. That's going to be assignment to mod. Get the total points. Now, to get this assignment, I can call it assignment updated assignment equal to gradebook.get assignment to mod. So updated assignment is an assignment object. And in an assignment object, how do I add? We are in an assignment. And compare score, get percentage, get points earned, student same assignment, some students same assignment. Okay, I don't have that in here. add it. Oh, create a new assignment. Create a new assignment. Step 11, get the assignment to mod. Call it setters for points possible and points earned. So this would be updated set points earned. And up here I had earned points. Set points possible. And that would be points possible. No, total points. Now, you might think I needed to set this thing back into gradebook, but in fact, the way ArrayList work is when I do this get, I am being given a pointer to an object which the ArrayList also has pointers to, references to. And so back in when we were talking about that memory model, I mentioned the word alias. You can have more than one reference for a particular object. And here, updated assignment is a reference. The ArrayList also has a reference. So when I have updated this guy here with those two statements, I have also updated it in the ArrayList. You have to pay attention to those kinds of things. So let's try again. And I will modify Sally again. That was 1? Yes. Select the assignment by number. 1, new total points, 150. And she did really well on that, 140. And so you can see that my grade book has been updated there. Here is where I was actually trying to create a new one. So I've got the name, the assignment name, assignment, new lab equal assignment and name lab, and now I have to add this to the grade book. I can do that. Tell you what, just for funds, let's put this in a different spot. We'll put it in position 1. I need to kill this. Need to save and compile that, and let's rerun. So 0 should make a new one. New student name is Zipper. The assignment name is Lab 3. And so now, since I added it to position 1, in position 1 is Zipper for Lab 3, and Sally and Jack were bumped to the next positions up. Again, please do not hesitate to jump in. And I can compare, but I did not. I was being lazy on you guys. And so I didn't do much in assignment. We can compare score. So now, Scores are ints, and ints are really easy to compare. Remember, I have me, which Java calls this, and I have the other assignment that I'm comparing to. And the typical way Java does compares is if I am bigger than the other guy, I return a positive int. If I am smaller than the other guy, I return a negative int. And if we're the same, I return 0. Now, don't let me forget to talk about dealing with floats or doubles when doing this. But the easiest way to do this when you're dealing with ints is just return, it's dealing with the percentage score, so I am dealing with a double. When you're dealing with ints, the typical way of doing it is to just return me minus other. Because if the other guy's bigger, that expression will wind up negative. If I am bigger, it will wind up positive and everything's fine. But you can't do that when you're dealing with floating point numbers because one might be 10.1 and the other one might be 10.2. And so that would return 0, which just isn't right. So what I would do, though, is have to do some ugly if statements. And first, I would probably calculate, get percentage minus other dot get percentage. And it's not get percentage. Yes. Oh, there we go. Okay. So if it's negative, the other guy's bigger. Now return -1. And it can be any positive number, so I'll just return 10. And if I don't hit on either of those, that must be the same. They must be equal, so I'll return 0. What was I looking at doing here? I was comparing assignments. Now, I have this method that I provided to compare two assignment objects. And it was just big, long, and ugly. And given enough time, you guys could write this. But again, I did this for a classroom setting, and I didn't want them wasting their time writing system out and getting all this stuff, so I did it for them. But we can use that. It's a void method. So we can compare assignments. And let's see what this gives us. Since I haven't finished the assignment class, it won't give us everything, but it may give us some things. Let me kill the old one. So let's compare, and let's compare, let's say the first one is going to be Jack, and the second one's going to be Sophie. So what my compare assignments does is Sophie in assignment lab 1 did better than Jack in assignment lab 2. They are not the same person. Lab 1 and lab 2 are not the same assignment. And if we play with that some, since Sophie and Sally did have the same lab assignment, since Sophie and Sally did have the same lab assignment, we can compare again, and we will compare 0 and 1. Sophie in assignment 1 did better than Sally in lab 1. Sophie and Sally are not the same person, but lab 1 and lab 1 are the same assignment. And just for one more thing, I can compare Jack to himself, which in Jack's mind would have been the only competition. So Jack and Jack scored the same, they are the same person, and so forth. So this is a lot of what I wanted to go through. Let me see, do we have any? You guys be putting your questions in the chat. One other thing I wanted to mention, it's a big temptation to copy and paste directly from a web page or a Word document or something straight into your IDE. That can pick up invisible, illegal characters, and since they're invisible, you don't even know about it. But if, like, I try to run it on my systems, they may well fail. So that's where you use the sanity checks. It's possible that you're going to see a sanity check failing to compile when you look at what the sanity check has and you look at what your code has and it looks like it ought to work. I can only say just please retype the line and see if the error goes away. Retype the line in your code, because it's really bizarre seeing characters that you, or having characters that you can't see there. So I can only say it's painful for me too. I wish it worked that way. Other questions? Please, go ahead.
So you mentioned in the announcement for the grades about not using the house class that we had used for the previous assignment. So by that, did you mean that we would get rid of anything that we really don't need to keep on with the subdivision assignment?
Oh, okay. Well, what did I say? Because your house should be rolled up into the project, so that I expected house.java to be in your subdivision program.
Right.
So did I say don't use it?
Yeah, I thought you were saying that we couldn't just use the one we had used from the previous assignment. I just wanted to get clarification on that.
Yeah, well, that's certainly...
Because I included house.java,
right.
So I had 3 Java files. I just wanted to make sure that that was okay going forward when we continue with the subdivision and then the project.
Yes. Can you point me to where I said that?
Sure. Let me go. All right. In the announcement for that the lab was graded.
The writing classes lab?
Yes.
Okay.
So turning in a program written for a previous version of this assignment receives a 0 for the entire lab. So by that, I didn't know whether we should rewrite house.java.
No. That, okay, maybe need to clarify that. No, when I said previous versions, what I'm thinking of previous semesters versions.
Oh, okay, gotcha.
Because the classes are tweaked, and so when I see somebody turn in a perfect program, but not related to the description of the program they were supposed to write, but perfect for last semester or something like that, I figure something not kosher is going on.
Okay. All right. Perfect.
Sorry about that.
No problem.
Okay. How are classes and objects used to build applications? Well, we have a simple example here with gradebook and assignment. And back when you were doing the widget viewer stuff, that was another case where you had your class, which had a main in it, and there was a widget viewer class, which you created an object from widget viewer, and then you created all sorts of JText fields and JLabels and so forth. And that's kind of how things are put together. If you can, I feel like I'm not communicating very well. So what? Joe Parks
is now exiting.
Hello.
Hi, this is Desiree.
Okay, something happened. I wasn't, and I guess he dropped off.
I think we lost the instructor.
Yeah. I don't have chat, but I was trying to send a
I didn't
request.
either. Yeah, I didn't have a chat either. It looks like everyone has left, so.
Yeah, I was gonna ask him if he can share the program because I'm still kind of. Maybe he gets back. Hello.
Yeah. Yeah, I think I'm gonna leave. Okay. Bye. Good luck.
Yeah, we'll see. I'm gonna wait a little bit.
Desiree.
Is now exiting.
Hello.
Joe Park. Hello?
Is now joining.
Hello? Is anyone else still there? Come on.